Hey everybody, and welcome back. Today we are going to be talking about rational exponents and radical expressions and how we convert between the two of those. So it's going to be a very simple, straightforward lesson. How do we translate between the two? You may need to recap on your laws of exponents from Algebra 1. If you don't know what those are or it's a little rusty, into Google, type laws of exponents and just take a look at what those different laws are and how different exponents impact the expression that they're being applied to, or how we can manipulate them to get different versions of the same expression. Essential question: how can the expression square root of 2 be rewritten using rational exponents? So basically, how do you convert from a radical expression to one using rational exponents? In the last video, we talked about characteristics of cube root functions. We identified the transformations of cube root functions, and we wrote equations from cube root function graphs. And we did the square root graphs right before that. So it is building on from there, and we are just digging more into radical expressions. Okay, so this is the key law that we need to learn about. So write this down, make a poster of it, highlight it, star it, whatever you need to. This is going to be the most important part of today. If you have any value, so I just use a here as a placeholder, but it can be any value, to the power of, or exponent, which is a fraction, so in our case m over n. The numerator stays as the exponent for a. The denominator is actually the root, so this is the nth root of a to the power of m, or it can be the nth root of a all to the power of m, so that you can write it either way. They're both correct. If we have something like 27 to the power of 2/3, that will be the cubed root of 27, all to be squared, or the cube root of 27 squared. Either way, it's the same thing. The cube root of 27 is 3, so 3 squared is 9. So if you are able to evaluate a numerical expression, you do so. Most questions I'm going to ask you is convert from one to the other, so from rational exponents to radical form, and then simplify if possible, or evaluate it if possible. Next one, 4 to the power of 3 over 2. So we would say this is the square root of 4 cubed. And you can leave the 2 out. Remember, 2 is one of those ones that you don't have to put there. It's like when you have a variable, we know there's a 1 in front of it. It's 1a, but we just don't put it in there if we have a in its own. So if you see the radical symbol with no number in there, it implies that it is a square root, so the second root. So let's see, 4 cubed is 64, so this would be the square root of 64, which is 8. So you can evaluate it either way. You can cube it first and then do square root, or you can do square root and then cube it, because the square root of 4 is 2, 2 cubed is 8. So you get the exact same answer either way. All right, let's just do a bunch of practice and you can see what we're looking for. So I'm asking you to convert from one form to the other. So if you have a rational exponent, convert it to radical form. If you have a radical, convert it to a rational exponent. And if it can be evaluated, so if it's numeric and it can be evaluated, then please evaluate it. So we've got the cube root. And typically, if the number is big, like 125, I like to do the root part first. So cube root of negative 125, all to the power of 4. So this would be the cube root of negative 125 is minus 5. So it's minus 5 to the power of 4. So that would be 125 times 5. So that's 625. So let's see, 125 times 5, 625. Yep. And this one will end up being positive, because you would have had negative 125 times another negative 5. So it would have been a positive answer. So 625. So I'm looking for the radical form and then the evaluated version as well. A calculator will tell you it most of the time, unless it's like an irrational number and you can only simplify parts of it. But check it out in the calculator to see if it does simplify to be a whole number. If so, you've got that part, but you still need to be able to write the radical form. If you leave any part out, you risk losing points. All right, x to the power of 11 over 8. So that is going to be the 8th root of x to the power of 11. And you can do 8th root of x all to the power of 11, or in this format, so where it's x to the power of 11 and then 8th root being applied to all of it. Can't be simplified any further, so we can leave it as is. All right, so now this time we've got 11, so it's in radical form, so it's going to be 11 to the power of 6 over 3. And 6 over 3 simplifies to be 2, and 11 squared is 121. So if your rational exponents can be simplified, like 6 over 3 is a fraction that can be simplified, you are allowed to do that, and then just simplify that final answer. All right, last one here, we've got fractions, and it's in radical form. So this is going to be 2x over y, parenthesis, to the power of 5 over 4. So nothing else we can really do here. The only thing we could simplify potentially is that 2, so this could be rewritten as 2 to the power of 5 over 4 times x to the power of 5 over 4 all over y to the power of 5 over 4. But I mean, 2 to the power of 5 over 4, I don't think is going to simplify to anything that's a whole number. So 2 to the power of, just checking it now. Now it's like 2.37. So yeah, there's no point in doing that. If it was something that the numeric part would simplify, you could do it, but there's no need in this case. All right, take a shot at yourself. We got 4 examples. Convert it to the other form and simplify if possible. Pause the video, come back and check your workout. All right, so let's take a shot at this. So we get minus 32 over 243 to the power of 2/5. So this is going to be the 5th root. We've got minus 32 over 243. So remember, this is a bigger number, so I want to do the root first and then all to the power of 2. So the 5th root of 32, or negative 32, is minus 2. And 243, the 5th root of that is 3. All to be squared. And you can apply the squared here. So minus 2 squared is 4. And 3 squared is 9. So this one does evaluate out. So if you have a fraction, the exponent will apply to both parts. So the 2 will go to the numerator and the denominator. Because remember, think of it, if you're squaring, it's 2 over 3 times 2 over 3, which is 2 times 2 over 3 times 3, or 2 squared over 3 squared. All right, 3y to the power of b over c. So it's all kind of, hypothetical variables here. So we would have the c root of 3y all to the power of b. You could also have written this as c root of 3y to the power of b. Now, emphasis on having the parentheses in there. If you do c root of 3y b, at the moment, the way you've written this, it is 3 times y to the power of b. Like the 3 does not get the exponent the way it's currently written. It has to be in parentheses if the exponent is going to apply to both parts. So just be careful of that. Next one then, we've got 3rd root or cube root of 0.5, which is a half. So I'm just going to convert that back to fraction. So we've got a half to the power of 9 over 3. 9 over 3 does simplify, so this is a half to the power of 3. And notice again that I have the parenthesis around the half, because if you just do 1 over 2 cubed, to me it only appears that the 1 is being cubed and not the entire fraction. All right, so then apply this, we get 1 cubed over 2 cubed, which is 1 over 8. Last one, u root of st all to the power of v. So st gets its own parenthesis, and then it's to the power of v over u. All done. All right, so that brings us to the end of today. How can the square root of 2 be rewritten using rational exponents? you would rewrite it as 2 to the power of a half. And then after today, complete Unit 5, Module 2, the rational expressions and rational exponents. Actually, that should be radical expressions, my bad. Radical expressions and rational exponents, and you also have a math task available. I will see you after the Christmas break for our next lesson.